How's the focus?
Okay.
Can you still see?
Okay. Now, well, this is from the homework last night, so if you didn't get it, you should be. This is a great opportunity to. Okay, I need to set up my axes so that everything's on it. Are all these points going to be on it? Is my 0, negative 12 going to be on it?
No.
No. Here's the pain with my computer. Actually, it's one of the annoying things about it. I cannot manipulate the x and y axes independently, which means if I go down to negative 14 here, which I think I need to, because where's my vertex at? Negative 14.25?
Mm-hmm.
Then I can't make the x's. The x's are, this is going to be a very skinny parabola, in other words. Show you what I mean in a sec. Okay, so
Then draw it.
my vertex, well, my axis of symmetry is x equals 1.5. That's about there, right?
Yeah.
Everybody with me? Even if you didn't get this, you can help me do this correctly.
Oh, I see.
How's my axis of symmetry?
Good.
Perfect.
Hardly, but thank you.
You couldn't get your roll out.
Okay, negative 14.25, bless you, would be around here, right?
So is that where you? Yeah.
Okay, am I good? So here's my vertex.
But then
My y-intercept is up here,
Oh my god, it looks really weird.
and my x-intercepts are negative 2.3, so I go to negative 2, and then I go about a third of the way to 3, and positive 5.3. So I go to 5 and go about a third of the way to 6. And now you get to experience my mad art skills up here,
Yay.
by which I mean...
Well, I guess I wasn't wrong.
And now, let's check how correct we are. The original parabola was y equals x squared minus 3x minus 12, correct?
Mm-hmm.
All right, you guys ready to judge my artistic ability?
Mm-hmm.
Could be worse. Fail, but not epic fail. Let's see. This thing will tell me my vertex. Can you read the numbers up there?
Negative 14.25 and 1.5.
Okay. It'll tell me my intercepts, close to. And it'll tell me my intercepts. There's my negative 2.27. There's my 5.27. That's my negative 2.3, my 5.3.
I
Okay. Questions on this?
Yes, actually. Well, not.
Has to be quick because I got to go on.
Okay, really quick question about the homework. Well, this homework.
No, only if it's about the how-to.
How to?
Okay, only if it's about the math, not about...
It is.
What? Okay, go ahead.
Well, not for this one, but for number 2. Is it possible that you can have an I in it?
No.
Anyone else get I?
No.
I don't think so. I tried hard to make sure it wasn't. Mimi, brace your eyes. I'm willing to say I might have made a mistake, but if no one else found it. How about if you and I take a look at that after class at this time? Okay? Okay. Now, here is the next thing. Okay, new notes for today, 5 February 2010. I don't know, back in how I wrote it in the military for no apparent reason.
Are you in the military?
Yes,
No.
You said that the first time we had it.
I think so, yeah. Okay, now, okay, here's what we're going to cover today. Parabolas with one or no X-intercepts. Okay, first a quick thought on this. Parabolas go infinitely to the left and to the right. So there is always a y-intercept. Always. Okay, so you always have to find one of those. But a smiling parabola that's above the x-axis or a frowning parabola that's below the x-axis won't hit the x-axis. If this is the part where if you're good at this stuff on the last couple tests, and some of you struggled with that, I know, this section will be a little bit easier. If the right person pulls out the right parabola out of the hat for the project, it could be very short. For example, parabolas with one intercept are perfect square trinomials. Parabolas with one intercept are perfect square trinomials. That's how these work. So if you were paying attention on perfect square trinomials, this part may go very quickly. So for example, if I ask you to graph y equals x squared minus 10x plus 25. Who remembers how to factor that down? Who remembers how to change that or rewrite it?
What do you mean?
What can you rewrite this as, Sarah?
X minus 5 squared.
X minus 5 squared. I can rewrite this
One intercept are perfect square trinomial.
So you factored
if
it?
you get one intercept. Yeah, we factored it down to x minus 5 squared. This tells me something, actually, and we're going to go into this a lot more later in the semester. But for now, when you're finding the x-intercepts, okay, you're finding when y is equal to 0. When you find the x-intercepts, you're finding when y is equal to 0. So if I solve this for 0 equals x minus 5 squared, can anyone tell me what number I can put in for x that will make this parabola, that will make this statement true?
What do you mean?
5. If x equals 5, is this statement true?
Yeah.
Okay. So what this tells me is this parabola has one x-intercept at the point 5, 0. Because when x is 5, y is 0. If you don't believe me here, plug it in up here and you'll get 25 minus 50 plus 25. 5 also makes this statement 0. So how do you graph this one? Well, first of all, what's the y-intercept of this one?
The 0.
This is the one x-intercept. Now what's the y-intercept going to be?
When x is 0.
When x is 0, right? And what do I get then?
25.
Yep. So that's 0 squared minus 10 times 0 plus 25. So the y-intercept is
0, 25.
0, 25. Very good. Now, what does a equal?
What do you say?
1. I see a meaning ax squared plus bx plus c. Okay? A equals 1.
B equals
Who?
10.
B equals negative 10, C equals 25. But I only remember A. Who remembers from December how A worked when we graphed these on the midterm?
Oh, it told you how many new options.
Yeah, remember that, guys remember that A was kind of like slope?
Yeah.
Oh yeah, only for the first.
Only for the first time over. Only once, yeah. Kind of like slope, only once. Always over 1.
Oh right.
Okay, so it's always A over 1, and it only works once. You go left and right 1, and then up that amount. You can graph this the same way that we did yesterday. But here's what will happen. When you get to the b squared minus 4ac for this one, you'll get 0 under the square root. And you'll only have one x-intercept. Okay? And you have to graph it using this trick with A that we did. So for this one, I would go ahead and graph it from here. I wouldn't do the quadratic formula because I found the x-intercept, and that's what the quadratic formula is for. I know the y-intercept, and I would use A to get 2 more points.
Wait, is it a parabola?
It's a parabola.
So where's the vertex?
The vertex, oh, good point. You know what? No, I glossed over that point. I should have mentioned that. I'm sorry. If it's a perfect square trinomial, the vertex is the x-intercept. If you think about it, let me show you a visual. Let me do this one visually a little bit, Nimi. Work backwards to your question, okay? Here's what it looks like. 1, 2, 3, 4, 5. I was taking something for granted and forgetting to say it, and that's a mistake. I apologize. Up here is 25. This is a rough sketch. I go over 1, up 1.
Okay, never mind. I know what you're talking about then.
So it looks something like that. So here's I'm going to give you guys kind of a logic question. Are you ready? Okay. Again, if you think, you don't have quite as much work to do.